Hello viewers, welcome to the second tutorial of our series in C programming. Today we are going to talk about data types, operators and expressions in C. Last time we talked about the first C program whereby we've seen what are the structures of a C program and also what do we mean by an identifier, what do we mean by a keyword or a reserved keywords, and then also we talked about what do we mean by the tokens. Like here we have said that if we are to elaborate this, one token, second, third, fourth, fifth and sixth. So we have said that we can have like 6 tokens in there. So a token is nothing other than a simple code that is forming a statement. For example, in one statement you can have many tokens. Are we together? Yes. So now then we are going to talk about data types. Here, remember I have told you that these data types, it is like how many or which capacity do you want to reserve in the memory. It is nothing other than the space occupied in the memory by a certain variable. Like here, when you say name, it means this name which is of type character. When you say only character, the system understands 1 byte, which means it's like when you are going to a hotel and you tell them I want a room, and that room will be accommodating, like for example, let me say 4 people, which means you want to reserve a room of 4 people. So for example, here if you want to check on the memory, so for example, if I say I'm going to write plaintiff, the size of integer is this percentage d of mine. Why percentage d? Because I want to return something of type integer. I want in number how many bytes, 1 2 3 4 something. Here we need to use a function called size of function. This size of function, it is also found in that very first library. So size of integer, if I say for example size of integer, and if I run, usually it will show me the size of integer is 4. Let me say for example, for me to structure my output, I can put it on n, which means this is /n. /n means this message will be coming to the next line. Let me say for example, I'm also saying another /n. If we do 2/n's, you understand that here there will be two spaces provided. This will be helpful when you want to structure your output. Like here on my integer, it is telling me that it is 4. Usually the size occupied by an integer in the memory, if it is 64-bit compiler, it will be 4. If it is 32-bit compiler, it will be 2. So for example, I want them to check for the size of names. Let me copy names. I want to check for the size of names. Remember, I have told you that each and every character will be having one byte. But then this name of mine, if I say, for example, let me search for car. If I say the size of character, it is telling me 1. So assume then here that I am just putting these names. I'm coming here and I'm putting names in. What do you expect to have? Can I have someone to tell us? Usually, it will be telling you the number or the summation of all the bytes of all the letters, which means each and every letter is 1 byte, which means then how many characters? There are 5 or 6 something. 6. How can we prove it? Usually it is 1 2 3 4 5. Then why 6? You can ask me like such question. How will the memory understand this? Let me give you a simple illustration. Why is it coming like 6? So when you are writing, for example, Eric, when you're writing like this, Eric, it means in the memory, each and every letter will be going to its specific address, and where the letters ends by, the system will put this null sign, which means it is where my string is ending by. Are you getting my point? Usually this one also, it will be counted by the system. So assume then, okay, assume that I am just giving you like this. So what are you expecting? Usually now it will be 7. Why? Because also this space that we have provided here, it will also be counted. Are we together? Yes. Then here we have seen that these ones will be having like this data type. So we are having different type of data types, and we will be going one by one in order to elaborate them. So assume then here we have seen how to check for the size of the data of the size of the memory that any data type can hold. So for example, here I want, for example, to receive the names together with the age. So I am going to declare another variable called age. And here in my age, I'm saying, for example, I am 28 by now. So here, remember, it is a statement. I need also to put the semicolon. But this age, as you can see, we have assigned on age something of type integer, yes, or number, but here we declared or we reserve something of character. It says, assume someone is giving you, for example, a cup, or someone is giving you any container to contain, for example, sand or even stones, but you are putting water in that container. Usually it will not work just because water cannot be fetched onto that container of stones. Are we together? Which means integer is the one which is the correct one. So you can say here, dear, here we can structure the message, dear name, you are, this is an example, percentage years old. What do I mean here? Usually here I am telling to my user that he or she is this years old. Remember what I mean here, whenever you want to place your variable, you need to put the variable or the data type specifier. If for example I say like this, I interchange these ones, it will also be another problem. Let me just see if I put here D. Remember this one will be, we in this very chapter, in this chapter where we are, we'll be seeing, no, chapter 3, we'll be seeing then what do we mean by these data type specifiers and what are the list of them. So if it's like this and I run, you can see that dear here, because I have used percentage %d, it has only returned the address where my name is. Wow, it will be giving me the starting address where my name is, but it will not give me the name of the user. So if I change here and I put s, you can see that now it is giving me the correct name. You are 28 years old. So if for example you want to say, okay, I want them to know how years old will I be next year, here you can also add +1, which means here you can be able to apply some arithmetical operations here. Dear Eric, so it means we need to structure the message. Dear Eric, you will be 28 years, for example, next year. This is an example of a message that we're structuring. Are we together? Yes, I think you are getting my point. So here, it's up to you then to structure the message accordingly. Dear Eric, you will be 29 years old next year. So here then, it is, we remember we are talking about the data types and the operations and the operators, and also what? Data types, operators, and expressions. So here, when we are talking about the data types, one by one we'll be getting to understand much more. Remember, we are having integer data types and also derived data types, whereby we can have those primitive variables like integer, character, float, long, double, and so on, whereby you can even just read these things in this slide, as all these slides, they are posted for your sake, for your own sake on the e-learning platform. And I will also be giving you all of these slides right in the description of the video. So here when we talk about these floating points numbers, you can have float, double, and long double. So usually here in the memory it will be storing 4 bytes for float, 8 bytes for double, 10 bytes for long double. The difference between float double and long double usually it is the precision point. Float will be having 6 numbers after the comma, double will be having 15 numbers after the comma, long double will be having 19 decimal numbers after the comma. So here we've talked about void and also the functions that void can return. So here on the variables we talked about it, and here we can have char, int, float, double, void, and also we can have structures, arrays, and pointers, and so on. So we'll be talking about each and everything in by using examples. So let us go immediately to this one. We talked about it. This one we've talked about it. This one we've talked about it. This one we've talked about the role of the headers. Returning function, I have talked about it. Message formatting using /n and so on. But here, let me just tell you what is this message formatting means. When we are going to format, for example, the message, here there's something that we need /n. Let me magnify for us to see. When we want to, for example, to go to the new line, you can use /n. /n means new line, or position the cursor at the beginning of the next line. /t means the horizontal tab, or to move the cursor to the next tab stop, means you want to provide like a space between something, you can use /t. /a, usually it is used especially in gamings when you want to give an alert to someone. This double slashes means giving one slash, and slash this one you can use it in order to give like these colors. Okay, for example, let's just practice on all this. For example, here I want, for example, let me add another message here down. Let me say I want to have a message like welcome to Awuka. So if I say, for example, welcome to Awuka like this, if I run, you can see that, okay, here there is welcome to Awuka, but then here, after the first message, the second message got it. So which means I can say, let me put /n to come to the new line. Are we together? Yes, which means then now welcome to Awuka is there down, but again between to Awuka and Awuka there is no error, there is no space. Can you provide a space like this? Well, I can even provide a space like this. Let us see if it works. If you do it like this, you can see now welcome to Awuka, but remember that tab, it gives not a simple space, it gives the tab space or the break. It goes up to the next break, so you can use like this. But sometimes you want to display, for example, the numbers by giving providing a space in between, then you can have like that one. So okay, this is it. Then we can also just be doing like this. For example, I want to give a space between welcome and process returns this message from the system. Here I can either print out, and when I'm printing out, I can leave a /n, which means I need to provide like a space like this one. This is the same as coming here and I provide /n here, which means it is the same like this. So you can use any of these in order to see how you can format your output. So let us go them. As we go, let us see what are these operators. The operators are nothing other than the signs to show which operation to be done or to be used. When I say operators, please understand that these operators, they are nothing other than the signs that are telling to the system or to the user what do we need to do. For example, if I show to you plus, you understand that then it is an operation where we are going to receive, and that operation is nothing other than the addition operation. All together, if I have minus, if I have division, times, modulus, the incrementation and the decrementation, here we'll be seeing this step by step. Here we can have like this one for the arithmetic operations or operators, and also the same rule will be applied. We can also see the relation operator, whereby we can check if it is equal, not equal, greater, less or equal, and greater or equal. The logical operators, where we can have and, all, and not, where the assignment we can have equal, plus equal, you can say plus equal to 1 is equal, divided equal, okay, something like this. All of this, they are available. Then thereafter we'll be talking about bitwise operators. Remember, for you to have an expression, we need to have what? We need to have an operator that is between two operands. For example, let me say here I'm declaring some variables, int a, b, and c. Then I'm saying that c is equal to a plus b, which means, what does this mean? This means there is an expression of a plus b, whereby we're having two operands, which are a and b, and one operator inside. So here it is what we mean by the operation. So we are going then to do like this simple, we are going to do like this very simple application to help us in order to manipulate this. So for example, this is not first program, but is operations and expressions. And I am going to delete all of these things because I want to start from scratch. Let me save. Let me call it ops and ops, operator and operations. So okay, here we remember that before using any variable we need to declare it, and here what we are going to do, for example, we are going to do an application whereby the user needs to input two numbers or three numbers, then the system should display the addition, multiplication, division, modulus, post incrementation, and also pre-incrementation, something like this. Let me say, for example, okay, I'm going to print out the user the addition of percentage d and percentage d, let me say for example, of a and b is, this one is c. But remember, these ones, if I give the message like this, the system will always tell me the addition of a and b is c. Yet I want to put real numbers, which means here I can declare something like int age is equal to 10, b is equal to 25 or 23, 25, then c is equal to a plus b. Let us see here, it will now work. So usually these are the ones. Then I'm saying that int c and my c is equal, for example, to a plus b. Are we together? I wanted to say my c is equal to a plus b. If I run like this again, you can see it is not being displayed. What should I do here? I need here to pass the three variables. For example, I can say, not even just this one, I can say c, and where there is c here, I need to pass the data type specifier. So when I say like this, it will tell me the addition of a and b is 35, yet we don't know what is a, what is b, in order to confirm, which means here I need also to pass a and b. So if the a and b have been passed, then here I need to use percentage d and percentage d to mean the specifiers from here. So for now, then it will tell me the addition of this and this one. It is okay. Here they're saying there is something, there is before age, there is something that you've forgotten, like comma. So which means here I need to populate a comma before a, right? So it will tell me the addition of 10 and 25 is 35. Now it's okay. So which means if you want then the subtraction, then it will be the same. The subtraction, let me say the division. Then here you understand that here you can say is equal to a minus, so usually here you can even just play like this, or even a divided by b. So all of these things will work. So you can see that, okay, the addition of this, the subtraction of this, you can see that we need to provide like the new lines at the end of each and everything, so that our message will be outputted in a good format. Wow. Wow. So now we'll be having the addition of this is this, the subtraction of this is this, the division of this is this. Here it is returning 0. Usually it could have been what? It could have been 0.4. But because here I have said integer, then integer is the number without decimal points. So if I want then to change this one, I can, for example, make it like float. If I make it like float, it means I am accepting some. If you make it like float here and here, you want to assign float things into an integer things. Sometimes also it doesn't work, or it gives you something strange like 0000, which means it is a problem of this integer. You need also to make it float, which means if you want to fetch water, you need to have something in which you need to fetch water in. So usually here float C is equal to this one. So for the front float, okay, this one. Let me say like this, and I also come like this. Sometimes float doesn't accept the assignment like this. Sometimes float doesn't accept the declarative assignment, but now it is not the case. It is giving me 000. Wow, this is very good. Is this the correct answer? No. What is the problem? Here, remember, it is telling me the addition of 0 and this one. Why? It is giving me 0 because here I have put it percentage %d, yet I need to provide what? Percentage %f for float. Here, if you provide this f, it means then it is for float. Are we together? So here then I can copy this for the sake of the time in order to paste them there, and then we have our output. Wow, let us see then how the magic works. Wow, the magic worked. So the addition is this one, but here now we can see that it is giving us how many numbers after the comma? 6. Yet we want like 1 or 2. So how can you do it? So I can say, for example, the output should be .2f. Let me see if it works. Like here you can see, wow, it is now 35.00, which means then here I can say .2f, .1f. Let me say, for example, .1f, so that here it means you want one number after the comma, you want two numbers after the comma, you want something. Are you getting my point? Yes, you are getting what I mean. So which means it is this one, it is very helpful when you want to format your output. Like right now, that means then I am receiving only one comma, one number after the commas. Are we together? Like here it will now be 0.4. Wow, this is very good. So when we're going to do this, then I can say, for example, let me print out. So let me say, for example, then it's my slash n, then I say plus plus, sorry, plus plus this one, plus plus age is equal all is equal to percentage f. Remember, I need to say it is a plus plus all plus plus a. What do you expect here? Usually when you say plus plus a, it first implements a, then it displays it. Let me see. You can see my a was what? It was 10, but now it is 11. Are you seeing? But then if I say a plus plus, what will be done? Here it will first print out A, then it will not, you here will not see, but in the system after printing it has incremented my A. Are you getting my point? Here I can say, for example, dot one, which means I need only one number after the comma. Okay, good. On the pointers, usually in this way, I am going to show you how then do you elaborate an expression, how do you evaluate an expression, and this will be very good. So here it was on arithmetic operations. This was arithmetic operations. Arithmetic operations. So let us just go to another type of operations or operators, whereby we are going to talk about logical operators. Logical operators, usually logical operators, I will also talk about these operators once we'll be reaching on once we'll be reaching on control flow statements, whereby I will need to combine, or even just to talk about the two conditions, and you can use this and or and not. So here we can say that these logical operators, which are and, which are or and not, these ones are being used and they are very useful, especially in control flow statement. I will just talk about this when I'll be reaching there. For example, you can say if A is equal to 5, 6, and B is equal to 7, which means if you passed with this course and you passed this course, which means, and it means you need to have the true from the left side and true from the right side. Are you getting my point? Yes, I am sure that you are getting it, and you will also get it practically when we be reaching there. So for example, then we let us go to another type of function or operators, which are relational operators. Okay, here as you have seen, here I have said if age is equal, sorry, here it is like this, because you are comparing, you're not assigning. If you use this, it means you are assigning. You are saying a, let a is equal, let a equal to b to 6. But if you are saying like this, it is like is a equal to 6, which means it will not change the value of a, right? Please remember to put two equal signs if you want to compare, and one equal sign if you want to assign a value to that variable. So like these ones also, I will also be talking about this once I will be on conditional statements. So the assignment operator, it is this one. We have used them here, whereby you have assigned this one, we can assign using this ones. All of these, the assignment operators. Are we together? So these are the operators then. Usually we will be elaborating these operators as we go or we continue our studies. So here, what I want here to say, I wanted to talk about these operators. So logical operators, we have seen them. We have also seen these relational operators, the relational operators. And also we have seen the assignment operators. All of them we have seen them, but I have told you that as long as we continue with these studies, with this series of tutorials, we will get to understand then how to use all of these. The assignment operator is where we are having like this one, the equal, the plus plus, the plus equal, something like this. So all of this will be elaborating how do they work. So last but not least, let us talk about bitwise operators. How does bitwise operators works? Bitwise operators, it works in a way which is very good. For example, let me use my Excel now that we elaborate this. Remember, for example, you are saying 5 and 4, and I'm going to remove this. And as we know, we are having the 2 power 0 and this 2 power 0, we're also having 2 power 1, we have also having 2 power 2, we're also having 2 power 3, we are also having 2 power 4, you're also having 2 power 5 until you go to 2 power n. So which means each and every number will be having somewhere or a slot in this 2 power something. Usually each and every number, it will be a combination of these numbers. So here we have said that, okay, this is 32, 16, 8, 4, 2, then 1. So what is 6? 5. 5 usually it is 4 plus 1, right? Which means I am having here 1, and here also I'm having 1, which means the remaining will be 0, and also here will be 0. Even the remaining will be 0, but these zeros, they are not needed. What is 4? It is only the presence of 1 here, and the remaining will be 0, 0. Are we together? So which means if then I am going to have like a bitwise operator, this bitwise operator, how will it work? This bitwise operator, we can have AND, all, NAND, and all. So here, let me say that, for example, I want to know the output of this thing. I want to know the output of this. When we are having AND, it means whenever you are having 1 and 0, it will be 0. And whenever you're having 0 and 0, it will be 0, 1 and 1, it will be 1. What do we mean? In AND, it does something like multiplication. 1 multiplied by 1 is 1. 0 multiplied by 0 is 0. And 1 multiplied by 0 is 0. Which means bitwise operator on AND, then AND bitwise operator will work like this way. So this way, then if I print out, if I come here and then I print out, for example, let us work on our 10 and 25. Are we together? If it is for our 10 and 25, it means I need to provide something here again, which is 2 power what? 2 power 6. But then I don't need it. So what is the okay, here I need 10, which is A, and 25. So we know that 25 usually it is the presence of 16 and the presence of 8, then it is 24, here 0, 0, then here 1. This is 25. Then what about 10? 10 is the presence of 8, which means here it is 0, 8, 0, 1, 0. So this is what we have. So then if we are having like these ones and we want then to apply our AND bitwise operator, here it will be 0, 1, 0, 0, 0, which means it will be this one. So what is this in full? It is nothing other than 8. Let us apply this and then we see. So we can say, for example, we want to print out, we want to print the value of A and B is, then I can put here percentage 1F. Let me say, for example, it is 1F. So if I come here, then I pass, or usually for float, I don't know what it's going to give me, but I can have this A and B. Let's see what will be returned. Usually here it is giving me an error that the binary float and float, the operand, it is invalid to binary. So this one, then let me try to change it. But then sometimes when we are developing some applications for low level, I'm going to use it like this, and I'm going to make this as comments. Sorry, I want to comment all of these things, and if I want to comment them, I know how to do it. So if we say is this and this, like here when we want them to have like this thing of ours, so here you can say this bitwise operator, when it is AND, it will display the multiplication. when it is all, it will display. Whenever we have 1, it will be, the output will be 1. Whenever, if 1 is there, then 1 is displayed. Then for this one, the AND operator, or the AND operator, we done it, and the OR operator, we done it. Then what about the XOR? The XOR operator, binary XOR operator, this one or this one, what will it be doing? Usually the XOR, it will be taking, as we have seen here, as you can see here, it will take whenever there is 1 and 0, it will display 1. Otherwise, it will display 0. When we are having, like here, this is 0 and 1, this is 1. Here, 0, 0, 0, 1, 1, 0, 0, which is this one. So usually these ones will be elaborating this, and also we will also study this in other concepts like digital computer fundamentals or intro info, where you've studied these ones. So after navigating through these bitwise operators, here you can say this is an example of question that has been given to you that you can use in order to understand much more what is this one. So my last step is to talk about the steps to modify an operator. When we say modifying an operator, what do we mean? Or modifying the expressions. For example, here we are having an example that I'm going to use in order to explain this. Okay, here, I'm sorry for this, usually this one we shall be working on it, but then here I can say, for example, let me say C is equal to A and B, and if you do like this, then you display C with your D. Sometimes it gives you the output that we wanted to expect. This is what we have seen, that it will be 8. Do you remember? This is what we have seen. We have seen that it should be 8, and 8 was nothing other than this one. I have forgotten to first clarify about it, but I don't know if one had a problem. Yeah. Okay. Here, let me just save this as mod and ops. Okay. So like this is our program. So the first thing that I'm going to explain step by step. This way, then this one is going to be like a comment, and this one to be like a comment. How does it work? The first thing to be done is to work on pre-incrementation. Secondly, you do what? After pre-incrementation, after doing the pre-incrementation, these are the steps: pre-incrementation, substitution, evaluation, assignment, and post-incrementation. If you understand these steps, these are the ones to be applied. These questions will be coming like in exams, in quizzes, like these things, and it's up to us to understand. So the first thing to be done is the pre-incrementation. When we say, for example, plus h, this is what we mean by pre-incrementation. And post-incrementation, it is a plus plus or a minus minus for post-decrementation, which means we need to start first of all on pre-incrementation and pre-decrementation. And remember, here we are having a, which is equal to 4, b, which is equal to what? To 6. So if we are having like this, let me say we are having our a, which is equal to 4, and b, which is equal to what? To 6. Then here, they have said that the first step is what? Let me rewrite the steps here. Steps. The first step was pre-incrementation and decrementation. This was the first step. What is the second step? The second step is substitution, right? The third step is evaluation. The fourth step is assignment. The last step is post increase and decrease. Are we together? So what do I need here? What do I mean here? And what do I need to do here? Remember that the question that has been given to us is A is equal to 4, B is equal to what? To 6. Then they are saying B is equal to A plus 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 B minus minus. The first step is to pre-increment and pre-decrement, which means, do we have any pre-incrementation here? No, these are all post. Then let us substitute. Substitution means here A, what is the value of A is 4, and what is the value of B? What is the value of B is 6. I am done with the substitution. Then let us do evaluation. Evaluation, remember that it is the same as operation or applying the operator, which is 4 plus 6, and here it is nothing other than 10. Then after evaluation, you assign. Assignment means B is equal to 10, which means I'm going to change this value here to 10, and here age, it will not change. I am still like this. I'm only assigning. The assignment operator is this one, right? Then next is post incrementation and decrementation. Do you have any post incrementation? Yes, it is A plus plus, which means A, it is becoming what? It is becoming 5, and B is becoming what? Is becoming 9. Let us see if it is true. So here, using our own logic, we are seeing that A will be giving us 5 and B will give us 9. Let me roll back to where it was. Then I remove this line of code for us to understand. Let me run. You can see, wow, it is 5 and 9. You have heard how everything is working. Let me say we go to the second example, which is A is equal to A minus minus plus 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 B. How will this work? The first thing to be done is to apply pre-incrementation and pre-decrementation. Do you have any pre-incrementation here? Yes, B plus plus, which means here B is going to be equal to what? B is going to be equal to what? To 7. Do you have any other pre-incrementation? No. Any pre-decrementation? No. Substitution. Substitution, it means A is equal to 4 and B is equal to what? To 7. Then we need to evaluate. Evaluation will tell us 11. We need to assign, which means A is going to be equal to what? To 11. Then do you have any post incrementation or decrementation? Yes, we're having post decrementation, which is A minus minus. It means then here we are having 10. So for now, we can expect to have 10 and 7. Let me just do like this so that we can see then if what we are expecting is what we are having. Wow, 10 and 7, it's what we expected to have. Are we together? Wow, you can see that here the same will be coming. So now I can give you like this whole question then to apply. What are we expecting from here? Remember, these whole programs will be executed line after another, which means the first one line to be executed is this one, the second line to be executed is this one, the third one to be executed is this one, then it will display this message. Okay, we are going to go step by step. Here we need to apply these all steps in all the questions. Are we together? So here, do we have any pre-incrementation or post-incrementation? No. No. Post-incrementation, we do have it, but there's no pre-incrementation and pre-decrementation. We go to substitution. Substitution means it is 4 plus 6, which is equal to 10. Evaluation, we evaluate and then we say 10. So now, for now, B is equal to what? Is equal to to 10. Are we together? After having this 10, then we are going to we are going then to see if we do we have any post incrementation or decrementation. We are having a plus plus, which means a is now equal to 5, and b minus minus, which means b is equal to 9. This one is done. Here I can write done. Then you go here, a is equal to, do we have any pre-incrementation and decrementation? Yes. Here we are having b plus plus. Remember, b was having 9, which means now b is equal to what? Is equal to 10. Do we have any substitution? No. So then we need to know, do we have any substitution? Yes. Here, b is equal to 10. A is equal to what? To 5. 10 plus 5 is equal to 15. And here it means that A is going to be equal to 15. Are we together? Then do we have any post incrementation or decrementation? Here we are having A minus minus, which means now my A is going to be 14. Here also this one is done. So you go here, B is equal to A plus 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 B minus minus B. So which means here we're having pre-incrementation and pre-decrementation. So which means I'm going first of all to increment A to 15, and here I'm going to decrement B to 9. So after this, I'm having 15 and 9, which is equal to 24, and I'm going to apply 24 to B, because this 24 is assigned to what? To B. Here it will be 24. Okay, so which means here also I'm done. So if I am going to print out this, I am expecting to have 15 and 24. Let me see. No, it is not. Why then? Why is this? Usually, if this is the case, it is not our problem. It is a problem of the compiler. Let me copy this. I'm going to come here back. I'm going to paste it here. Remember, this is our things. Oh, I'm sorry. It is not this. It is me who had a problem. Just because here I have been changing. So this way then I'm having this one. But remember what we had before. Just because I am changing, and then it is not seeing the other font, something that we had. Let me go in here and check what we had before, right? So here we had A4, B6, right? A was equal to 4 and B was equal to 6. I have been telling you that we are expecting 15 and 24. Let us see if it is the one. 15 and 24. Wow, this is it. So this is what we have seen in our system altogether. So this is how then you can evaluate an expression. So after evaluating an expressions, then we are going to see how then do we do some other cool stuff in expressions. You can also find some list of questions and answers right in the video description link. I will be giving you a link to those questions whereby you can do the practices in order to equip yourself with some understanding in C programming. Thank you very much. If you have any question, you can please ask or leave a comment in the video description.